In this tutorial, we will cover how to do a pick and place operation in Grasshopper using Kuka PRC. Right now I have set up the Kuka PRC RPO template and my pick and place template. In my pick and place template, I have a pick and place map that we will use to map our pick objects and the placement of our pick objects. I also have tools. I have my tools mapped directly onto the world origin 000 with two different states, open and close. To begin, let's start by setting up our tool. So we need to input a custom tool component. And we need to go ahead and set it. So I know my tool height is set to 205 in the Z direction, so I can go ahead and put that in. But I also know that we're not going to do any plane manipulation. And in order for our planes to map correctly to our tool, we need to add a 90-degree rotation in the negative direction on axis B. Our tool number is going to be 6. So once we have everything set up, we can hit confirm. Because I'm doing a multi-state tool, I need to create 2 of these, as well as a mesh component and a mesh color component. So we can copy these. Well, actually, let's make a swatch. Do purple, and then copy this, and we can change this to checkbox. Very bright colors that we can easily catch on to and know when they change. Map these here, and now we can set our mesh. Have my meshes already set to one mesh and joined. Our first one's going to be our open mesh, our open tool state, and our second one is going to be our closed tool state. I can hide this. Now we can see our open tool and our closed tool. So our tool is properly mapped now. We can set this off to the side. We can now import our pick and place map. So what I will do is I'll get my curve component out and set multiple curves. From here, we actually need to project this to the world XY plane. So type in project and map our curve to that geometry. We need to actually map on to and move this pick and place map from this exact point where this rectangle is. But this is where we will stack our rectangles, our bricks, to move during this pick and place operation. So we can get out our area centroid or area command to find the area centroid. Map our geometry to geometry and use a list item component to map and find the correct curve. hide all this, like this. And search through it until we get to that area centrally. We can now do a vector 2 point in order to move it. So what I need to do is actually construct a point and map index values to it. So we'll start with negative 500, move it 50, and then positive 500. And then map this to X, map it again to Y, and map it again to Z. And from here, we can do a vector 2 point to get a translation vector in order to move our geometry. So type in the move component, take this vector, our transformation, and our curve to move. Now we can use these sliders to position our geometry directly in front of the robot. That looks about right. So we can group this all together and call it pick mat setup. Pick mat setup. Alright, now that we've established our pick mat, we need to establish a pick location. So we'll go in and do another list item. And from here, we will map the same index with the same now moved list of curves. From here, we'll get the area centroid again. And now we have established our new pick location. We'll group this together, and we can note this as our pick location. Next thing we need to do is establish a place location. This is slightly different, for we will need to change our actual index value. We need to find out what is the location of the point, the center point. So if we map through it again with our list index highlighted, we can get the centroid and map our place location. Let's group it together. We call this place location. Now we can deconstruct these points. So we can manipulate it parametrically. We're going to need to also construct these points. And use a series of addition components and sliders, so we can actively manipulate geometry with them. Let's make this a little bit bigger. With this set, we can copy it in series of 3 times. And we can map our X to X, our Y to Y, and our Z to Z, and put these into position as we reconstruct our pick location and again with our place location. The next thing we need to do is build a set of pick object and place objects. Now that we have properly and parametrically mapped our place and pick locations. So for our pickup objects, we need to construct a box. We can use this brick wall script I created specifically for this tutorial to retrieve it. So copy that and bring it in and move it into place. So the objects that we will be picking up are this box. We don't need this right now, but we do need this box as well as these XYZ coordinates. So in order to have this right for now, so in order to actually move this box into position, we need to deconstruct it as a brep. So we map our box to the brep, and we need to do a list item to get all the faces. So list item, and we're going to look at our faces, slider up around 8 until we find the proper one. And list item we want is the bottom, and from here we're going to get the center point to map to the center point of our rectangle. Area centroid, and get the center point, and then we're going to do a vector 2D or vector 2 point in order to transform our box, which is going to be our A, to our place location, our pick location. Pick location at the top, we're going to map it to B. Then we're going to do a move command to move the box using this vector. Now I see that our box is too small. It's about 1/2 as small, so make it 100, 50, 50 tall. And now we have a equally sized brick or rectangle that we can now change and manipulate parametrically. From here, we can leave it alone for now and move on to our placement object. So right now we have a series of points that are mapped in the formation of a brick wall, but they are not mapped to our placement area and they are oriented the wrong way. So the first thing we can do is actually rotate this geometry. We can take in this wall. Well, since it rotated it for us automatically, we can now use a list item command in order to move it to the correct location. The point we actually wanted to map to is the first point, the starting point for our brick wall. So we don't need to actually indicate what index we want, but we do need to do another vector 2 point command to move our geometry. And B is going to be our place point. Then we can signify a move of the wall with the vector. We can lift this off to the side. Now what we need to do for our actual pickup objects is create multiple of them in the vertical direction. So what we can do is do another move command, and we need to move it in the unit Z direction, but we need to give it a certain number of, we need to copy it a certain number of times. So what we can do is create a list length, because we need to copy the same amount of points in the brick wall. So if we do a list length from the brick wall, we can know exactly how many to actually add. We can move up our individual bricks in the Z direction, same height as Z. Map that to our Z transformation vector and plug it in. Plug the geometry into the geometry. And now we have a series of bricks going in the positive Z direction. So with this, we can now copy all this together, or group it all together and call this our pickup objects. And we can copy all these together and group them together and call it our placement objects. Okay. Oh. So we can now hide all of these. Do all. Do all. With everything set up, we can now set up our placement points. So with this setup now, we can establish our pickup points and our placement points. So our first pickup point, we need to actually get the area centroid again for each of our boxes. So type in area centroid or area, map our geometry to that, and now we have a series of points within our boxes for our gripper to go to. From here, we need to actually rotate our geometry so our tool can map to it. Let's go ahead and finish up our custom tool. So we need to input a multi-state tool since we have two states. So our open goes in first and our close goes in second, and then we map this into our core component. You can see now that's properly mapped, but because this is coming out in a weird direction, we know we need to rotate our plane so our gripper can properly pick up our brick. So we can do a plane rotation or rotate plane. Takes in radians, and we know we want to rotate it 90 degrees. We can put our degrees in, put our radians in, specify that plane. And now we have a pickup point for each of our objects. The only thing is it's going in the wrong direction because we started our brick from the bottom and worked our way up. We need to actually reverse this so the robot picks up the top brick first and the bottom brick last. So if we reverse this list, using list item, we can see that it's now hitting the right brick first, or it's now going to pick up that top brick first. And it is. So we can make a group for this and call it pickup point. The second thing we need to do is actually specify the height after our pickup point. So we can copy this down. Actually, we need to make it a move component so we can actually move this up. So take this plane, map it to the geometry, and then use a unit z vector to move it in the positive z direction. We want to move it up 50 millimeters. And now we have our height after our pickup point. Let's group this. Alright, and then for our placement point, we can go ahead and group this as our placement point. But we need to specify the height after our placement point, or height before our placement point. So what we need to do is create another move command, map this geometry to that move command, and then use a similar unit z function to move it up. This time we'll move it up a little bit more. Let's increase our range about 250, and we can set our value to 200. Map that there, and now we have our height before placement point. Lastly, let's create a list length for our series of commands. This will be very useful as we work through creating commands to map our brick to the brick placement, our brick wall. So we need a list length of anything, really, anything coming out of this brick wall component. I plug it in, I get a list length of 11. That will help us as we create a list of commands. For our series of commands, we will use the command weaver component. We need 17 inputs because there's 17 different operations that will take place as we pick up a brick and place it in the correct position in our brick wall. So the first thing we need to do is actually set up our gripper. We need to make sure that it's open. So in order to do that, we need a series of digital output commands. So the first thing I'm going to do is type in scribble so we know what we're working with and what the first operation is, and it's open gripper. This will actually go for the first series of operations. Let's use the font, make it big and bold. Okay, and bump it up to about 50. Actually, about 40. Let's see how big it is. Okay. Move it all the way up because we have 17 of them. And the first thing we're going to do is type in digital output. So digital output takes in a number for the output. We know that the one we need to open is going to be 2. So let's type in a 2, get a slider for it. We need to create a Boolean toggle to tell it to turn on and off. So if I type in true or bool toggle, change this to true, I can now edit the state. Because we are using a multi-state tool, we need to actually map the tool number So the first tool number we're using for open is going to be 0 because that's the one we inputted first. We make it smaller. Can't set it up. Okay. Second thing we need to do is create a duplicate command because we need to duplicate this data. It's the same amount of times. With the list length command, we can go ahead and pull it in there and duplicate it the same amount of times as the length of items in our brick wall. We can copy this and make a number from it, 1, and that's going to be our first set of commands. Second thing we need to do is turn off our state 5. Our digital output number 5, and we'll change this to command 2. And this kind of concludes our open gripper sequence. Using group to lock it all together, and we can map our 1 to the 1 and our 2 to the 2. So now that we open the gripper, we need to move our robot to the point-to-point, or the point above the pickup object using a point-to-point movement. So we can kind of we can copy this and drag it down and change this to point-to-point movement. To point above pickup object. Really big so we know what's going on. We need point-to-point movement. We can set the velocity to 5. And now we just need to input our plane, which is the height after the pickup point. All this together. Copy the number down. Set it to 3. Click OK. And group it together. With this command, and throw it into number 3. And now we can move to the pickup point. From here, we need a linear movement to pickup point. Change this to 4. The speed is no longer in percent. It's now in millimeters per second. We put it at 0.02. And we can change, we need to change this to a linear movement. To pickup point, we can group this all together and tie our 4 to our 4. Move all this up. Now we need to do a series of digital states to close the gripper. So what I would do is I'll copy all this, put it down, and the first thing we're going to do is close the gripper. Alright, but before we close the gripper, we need to add a wait command to it. We want to wait for about 1 second, and we also need to duplicate this. So after we duplicate it, we want to turn our state 2 to false, and we also need to change our tool number to 1 because we're now closing the gripper, and 1 is mapped to our closed gripper mesh. Take these numbers, 5, put this to 6. So we're changing this to false, and we duplicated it, and we need to do the opposite for this one. We need to change this still to 1 because we're closing the gripper, but we need to change this to true. Let's duplicate it correctly, change this to 7, and now we need to add another wait command before we proceed on with our movements. So we can change this to 2. We're still going to duplicate it, and this will be our 8th command. Combine it all up. Add it all up. And you can set this. Let's tell this to turn off the open state. We can set these to turn on the closed state. Make this a group. Make this a group. And make all this a group. Now we can map the 5 to the 5, the 6 to the 6, and the 7 to the 7, and the 8 to the 8. So after we do the close state, where we close the gripper on our brick, we need to move it back up to the pickup point, or the height above the pickup object, which is the same thing as this command. So if we just duplicate this all the way down, so it did not duplicate it. Yeah. Just duplicate this all the way down, change this 3 to a 9. Group it and move it. Move this point-to-point movement into point. So the next thing we need to do is do another point-to-point movement to the height above the placement object. So if we copy this one more time, change this to a 10. And rename it so we know what we're trying to do. Point-to-point movement to point above placement object. To point above placement object. We can map this to the height above placement point. Group this together. Then move this command into place. 10 plus 10. Alright, now we need a linear movement, similar to this linear movement, to the placement point. So we copy this, bring it down, linear movement to placement point. Bring this to 11. And we need to actually map this to our placement point. Alright, from our 11, we map it into our 11. And we can now do another series of state inputs to open the gripper to release our brick. We brought it down to our placement point. Now we need to let it go. So we'll turn this into our closed gripper, our open gripper. Turn our closed gripper into our open gripper. And then we need to turn on the open state inputs. Change this number to 12, set it to 13. We need to change this false to true. And we need to change this back to 0 to show that we're letting our object go. The same thing, we're just going to turn off the true and change it to false there, and then map this to 0 for our tool. I'm going to change this to turn off the closed state inputs because you're letting the gripper be open now. We can change this number to 14 and this other number to 15. And then proceed with the grouping. Group this all together. Ooh. And now we can map everything into place. We can map our 12 to 12, our 13 to 13, our 14 to 14, our 15 to 15. And lastly, we need to do another point to point movement to the height right before we placed it. So we copy this one. Bring it down, change it to 16, and then map it into place. With this, we can group it. And lastly, when I add an axis movement to reset our robotic arm to make sure we're not creating any singularities or unwanted joint rotations. So in the template, I actually put an axis move in here. We can just move this down into place. You can copy this and call it axis movement. We leave the defaults on, and we can just duplicate. And yeah, we can duplicate the movement the same amount of times. Disconnect it. Disconnect all. Put that into place. Add the last number 17 down here. And then proceed to group everything. And then map 17 to 17. So now we have a series of commands. From here, all we have to do is put our commands into our KUKA core component. And it looks like everything's working out properly. So now we have mapped our actual pickup objects as this brick stack into the series of brick walls. To help us visualize how it's going to look in the end, we can do another move command down here. Move to point. Still move to point and see if that helps. So we have our point A, our box point, which is not set up. Do construct point. So now we can actually visualize how everything's actually going to look. So one thing we do need to do is move our placement points up halfway, half the height of the actual box. So after adding this area component, I was able to successfully map our brick into the correct spot. So now we can see after manipulating the placement point by increasing the Z height by half, the bricks are now in the correct spot and the simulation is now accurate. So one thing we can do now is check to make sure everything is behaving properly by going to the analysis tab, increasing your loop speed significantly, and hitting play. You can watch a simulation of the robot actually going into position to pick up and place your brick. So be sure to check the whole thing before running it. One thing I also suggest is that you increase your pick location by at least 50 millimeters before running your file. So by increasing your pick location in the Z direction, you can guarantee your file doesn't have any errors when you're running it on the machine. Make sure that you don't have any objects in place, but that you use this time when the Z height is actually higher in order to accurately position your placement map. And from there, you can actually run the file and make sure that it works.